Yes, good evening, Doctor. Good afternoon, Doctor. It's Enoga Frank. This is a project which I try to do. It is concerning about cloud forensics in virtual machine using transparent deep learning neural network, deep learning techniques. So this is the introduction. There is a growing number of cloud-based services. And due to the growing number of cloud-based services, there's also a growing number of cyber crimes. So there is need to find out and investigate the crimes which manifest within the virtual machines, within the cloud ecosystem. So I developed 4 deep learning models. That is the feed differential neural network, that is the same as multi-layer perceptron, then convolutional neural network, then recurrent neural network, long short-term memory network to automate the process of evidence detection and acquisition. I also applied explainable AI techniques, that is LIME and SHARP, on the feed-forward neural network and RNN. Because the other models I tried to use SHARP and LIME, but they refused to really work. So, but MLA, that is multi-layer perceptron, and RNN, those ones they worked with SHARP. The performance of the models was evaluated using precision, recall, score, and accuracy metrics. And from the experiment, that is feed-forward neural network, MLP, and RNN performed to the best. So this is a literature review concerning the research project. So this is a paper. It talked about how CNN is used in the field of forensics, and it used the images to obtain the evidence, plus also multimedia data in order to extract digital evidence from the multimedia. So this second research paper used a number of deep learning techniques, that is CNN, LSTM, GRU, MLP, RNN, to address the challenges of detecting evidence from network traffic, intrusion detection system, IoT, and the cloud forensics. This third research paper is what we call a network intrusion detection system using CNN in order to detect crime or to detect digital evidence or to extract digital evidence from network traffic in order to determine which data normal and which one is anomalous. It uses the SCP, principal component analysis, and SVD. This other research paper used the CNN to extract data on images and multimedia and other multimedia data. It used a classification algorithm in order to identify which data is classify which data is attacked, or to determine which data has been attacked and which data has not been attacked. Then this other research paper used it was about enhancing trust, ensuring trust in deep learning models in the field of digital forensics. So this one used the ResNet, that is ResNet. These are neural networks. Now this ResNet here has 101 neurons This one has 150 neurons. This one has 16 neurons. So ATF was employed in order to test for the execution robustness of the black box structure. So this paper, it basically used this framework in order to in order to determine, to test whether deep learning models are performing the work of what? Are performing the work of what? Digital forensics. So that's why they are talking about the black box structure of NN. So they wanted to employ this in order to determine whether these techniques really do the work. Problem statements. Now the problem statement. Now due to the data that has been the huge data that is generated from the internet or from the cloud, it is hard for crowd forensics investigators to determine which data is evidence data, which data is non-evidence data. So due to that problem, deep learning neural networks have been developed in order to help crime forensics investigators with only the exact data which can be used for crime investigation. There is also need also for crime forensics investigators for this to learn, to know how these deep learning models are making their predictions. The objective is to implement deep learning models for evidence detection in virtual machines using transparent deep learning techniques and explainable AI. So specific objectives, the specific objectives is to implement various deep learning models to help crime forensic investigators to extract evidence data for crime investigation, and then demonstrate how explainable AIs are used to explain how the deep learning models are generating the what? They are generating the predictions and the classifications. Research contributions. Now this research will help crime forensic investigators by providing them with only really precise data that can be used to track hackers, malicious actors within a cloud-based ecosystem. Now the data set here, this data set was generated from IEEE-dataport.org. So the data set has 43 features and 9,610 rows. So this is the data set generated using a private cloud from a computer system having these specifications. i5 Intel Core processor, 2 GB of RAM, and 1 TB of hard disk space. The private cloud was set up using a 3VM type hypervisor and Open Nebula as a cloud computing platform. Now this is the methodology. So I input the features, perform data processing and analysis. I clean the data, perform the data analysis. I built the model and train these models across 50 epochs. And then the model generated predictions, and then the model evaluation was also performed. Then I invoked the explainable AI techniques, that is LIME and SHARP on FN and RNN. This is the distribution of the target variables. Target variable, so this is 96.0% representing normal data. Then this one representing that which has been affected. Now these virtual machine IDs, these virtual machines have been infected, have been abnormal. Then these are attacked. This is a correlation matrix showing the higher, this one's in green, was positive correlation or are strongly correlated. These ones which are lighter green and up to red, those ones are negatively correlating. So this is the performance of feed-forward neural network, as you see here. Both two negatives and two positives are many, representing a better performance of the model. This is the training. This is the curve showing the training of the models across 50 epochs. This model across 50 epochs. And the value was 97, it kept on rising. It kept on rising. It was 97.0 at the first epoch. This is also the performance of CNN, as you can see here also from the confusion matrix. This is also the curve showing the performance of the CNN from the first epoch up to the last epoch of 50 epochs. The same for RNN. Deep learning models. This is a table showing the results of the performance of the models. So as you can see here, the neural network and RNN, they are the best models. Then the low performing model is LSTM. That's why even the binary cross entropy is very low. It's high actually, the binary cross entropy is the one with the highest binary cross entropy. So this is the performance of Lime. I made a mistake here. Lime, as you can see from this virtual machine instance, no data has been compromised. However, there is some comment of data compromisation, but most of the data which has been stored on it or fetched on it has been normal. And then these other ones, the data has been compromised. So the blue means data or that virtual machine is normal or not being affected by any malicious actor. Then these two here, this blue color here, bleak red shows that the data has been compromised on that particular virtual machine. And these virtual machines here can be used for extracting digital evidence, crime, or by computer crime forensics analysts. This is the performance of Sharp explainable AI. So there's no difference, as you can see here. The first virtual machine instance is normal, the second affected, then the third one infected. So this one emulates the performance of the two virtual, the two explainable AIs. The explanations are matching. The visualizations are matching, as you can see. So this is the feature importance of Lime, of Sharp applied on RNN, showing the feature importance, the features which are most relevant for making predictions by Sharp. So TX packet slope, RX packet slope, and TX byte slope are the most relevant features. So these ones here, these ones contribute less. They contribute less towards the model prediction. Conclusion. So from this research here, we can ably see the role of artificial intelligence, especially in adoption of deep learning, especially in deep learning, specifically the application of explainable AI techniques and the application of deep learning models in classifying and detecting crime within virtual machines in a cloud computing environment. These advanced techniques are steadily replacing the traditional methods and processes that are too manual and slow at acquiring and detecting digital evidence from the cloud. That brings out the rightful explanation and visualization for the prediction generated by RNN, RNN. Then the SHAP can be employed for explainability and interpretability. One, the SHAP I got I tried to get some good explanation, and the visualization really, and the visualization try to match with what we experience. Because now, if you can hear, the lower the packet transmitted on a network, then the lower that particular virtual machine will be what? Will be infected. That's why the virtual machine is 0, 0 here. It's predicting a 0 because 0 is it? Those are virtual machine is empty. What is it? Then the higher the packets now for this other visualization of the post plot here. The higher the visualize the packets, then the greater are the chances of that particular virtual machine to be what? To be infected. The same applies to this. That's why there is a 1 and a 1. A 1 represents compromisation. The other represents no, or less what? Or less compromisation. But this one, I fail to understand how to make it, because now, because here, the thing it is somehow inversely proportional to what we know on the ground. So FNN and RN perform to the best as compared to LSTM. Limitations: SHAP consumes a lot of computational resources in terms of memory, because generating one false plot was taking over 37 minutes, and generating this curve here, this feature importance for RNN, it took around 2 hours. Then in the future, I would recommend to also apply LRP and gradient-based techniques, explainable AIs on the models. And this, I would like to thank Dr. Galiwango for his selfless effort and willing to share and experiences so that we can come up with his presentations. I've really liked your contributions, sir. Thank you so much for giving us this knowledge here. Thank you so much. That's the end of my presentation. Thank you.